Okay, so let's try this question. This one says for the function g of x equals 9 minus x plus 1 squared, do all these things. So, before we even start this, I would say whenever you see some function like this, think of the parent function and then what transformations were applied to get this. So if we, here, let's think about it like this. Take a look at Desmos. So we have g of x. This thing, the parent function here, right, it's something x squared, right? That's our starting point. So we're going to start from x squared, and whenever you think about the transformation, you want to go inside out. So the first thing we're going to do is this plus 1. And if you remember, plus 1 next to the x is always flipped. So it's not to the right one, it's to the left one. So right, so this is it's a translation of the function to the left one, right? So here we have this parent function, g of x equals x plus 1. Look at that. Left one, right? I shifted to the left one. Next, this minus sign is stuck to this parentheses, right? So this is the next thing. We're going inside out. So the next thing is we're gonna take. Sorry, my pointer is missing. Okay, so yeah, we're gonna take this minus sign. We're gonna apply it, and a minus sign in front of the parentheses. That's gonna flip it, right? That's a reflection over the x-axis, right? If it's minus sign in the front, it's over the x-axis. If it's minus sign in front of the x, then it's over the y-axis, right? So then this, flip it over the x-axis. So if I keep going with this, this is to the negative x plus 1 squared, right? Take a look at that. So it went from here to here, that's the left one, and then from here to here, let's flip it over the x-axis. Finally, the last transformation is, there's a 9 here. It's like adding 9, right? So this thing is telling us, hey, go up 9, because it's outside of everything. So it's going to be a vertical. It's going to go plus 9, so it's up 9. So finally, this final transformation is, I guess I can write it like this. This would be the correct order, right? So if you can see, so again, we went from left 1, flip it over the x, and then up 9, right? So we're here now, right? So when you see something like this, you want to think, oh, that's an x squared function, right? It's a quadratic function with all these transformations applied. That'll help us, right? If you can do that in your head, that'll be very helpful. So yeah, this is kind of in vertex form. So all right, so let's get into it. It says sketch the graph of g of x and the axis provided. Now, here's the thing though, honestly, if you're gonna sketch this, I would just plug in values, right? So there's some things to think about. So I would say, hey, think of this as, like I said, this is like in vertex form. You can rewrite this, this is negative x plus 1 squared plus 9, right? So this should stand out. This is in vertex form where the vertex is negative 1 comma 9. That's our highest or lowest point. So, and there's a negative in the front, so that's opening downwards, so this should be our highest point. But I would think of this as, this is our midpoint. Remember, parabolas are symmetrical, right? So then I'm going to put negative 1, that's our midpoint. I'm going to put that in the middle somewhere. And I'm going to go, I guess, down 2 values, and then up 2 values, right? And then this should kind of, yeah, be symmetrical, like I said. Okay, so I kind of had the work here, right? So we pick the minus 1, we plug it in, or sorry, we pick the minus 1, put it in the middle, and then we go, probably go 2 down, 2 up, plug it into our function to get the y value, and then create a third column for the coordinates, right? So that's what this is, and then from here I would just graph these. That's negative 3 comma 5, negative 2 comma negative 8, sorry, negative 2 comma positive 8, negative 1 comma 9, and then again these are symmetrical, so if you have one side of the thing, you can probably get the other side. I should have probably went one more, because from Desmos we know that, yeah, it's negative 4 comma 0 and then 2 comma 0. Okay, but in any case, this is probably the best way to sketch this. Just think a little bit strategically, right? Think about, okay, it's a parabola, find the vertex, and then move, like, pick points around the vertex to make it easier. Okay. Yeah, and then make sure you put arrows here. You probably make it go more down. Okay, that's that. Okay, next part. It says state the zeros of the function. Now, this is very important. So the zeros of the function is the same thing as the x-intercepts of the function, right? So these are the zeros, and it's called zeros of the function because this is when y equals 0, right? If you think about these coordinates, this is like -4, 0. This is 2, 0. No matter what, if it's on the x-axis, it's something 0, and that 0 means y is 0. So yeah, this is what we're used to doing when we solve these quadratics. Okay, so here I just solved it out. So to find the zeros of the function, we set the entire equation equals 0, and then isolate for x, right? So you can use quadratic formula, or you can try it by hand. So -9 on both sides, flip the sign, square root, you get plus or minus 3, you have two situations, 3 equals, and then -3 equals, because we square rooted, and then solve it, so you can get x equals 2 and x equals -4. So we say that 2 and -4 are zeros of the function. Okay, for the next part, it says over what interval is g of x decreasing. Now, if you think about that, let's say we didn't have the graph. That's when thinking about the parent function and then all the transformations that happens, that's when that comes in handy, right? So, for instance, we can think of this as, oh, it's left 1, flip over the x, and then up 9, right, starting from a parabola. So we know that it should look something like this, right, more or less. I know there's a graph right here, but still. Let's just say, right, if you had to just do this in your head, it says what interval, over what interval is the function decreasing. So we can think, hey, that's always from the vertex, right, whichever vertex, and then since it's opening downwards, it's vertex and to the right. And interval, that's always the x interval, so we can say, hey, it's to the right of x equals -1. So it's when x is greater than -1. Yeah. So it's decreasing, it's going down as we go to the right of -1. Okay, and then the next question, over what interval is g of x positive, right? So when you see this, read it as positive. So g of x, which is the y coordinate, right? That's the y-axis values. So g of x is positive, right? I kind of see this as that's everything above here, right? Everything here is something comma positive y, right? So g of x is positive above the x-axis, but here it's asking what interval. Again, that's the x values. So g of x is positive between the two zeros. So it's between -4 and 2. So when x is between -4 and 2, the function is positive. So that's it.